Hello everyone, my name is Linh Nguyen and I'm from the University of Ostrava, Czech Republic. And today in my presentation I would like to present a procedure or a method to integrate the probabilistic uncertainty to fuzzy systems in fuzzy natural logic. And here we can see the outline of my presentation. First of all, I would like to present basic knowledge about fuzzy natural logic, and then I will extend the fuzzy system in the logic to the probabilistic fuzzy system or probabilistic fuzzy linguistic description. And an example is considered in the illustration section, and finally is the conclusion. What is fuzzy natural logic? Fuzzy natural logic is an extension of mathematical fuzzy logic. It aims at the modeling of human reasoning that proceeds as in natural language. And this logic was proposed by Professor William Novak. More detail about the logic can be found in the book Insight into Fuzzy Modeling. To have a simple image about the difference between fuzzy natural logic and standard fuzzy logic, we can see the difference is on the interpretation of fuzzy linguistic expression. For example, here we can see we have a set of several fuzzy linguistic expression. For example, small, medium, big, extremely small, very small, and something like that. And in the interpretation, we see that in standard fuzzy logic, each linguistic expression is modeled by a fuzzy set. Similarly, for fuzzy natural logic, this is also fuzzy set, but the difference is that, for example, the point 0 here is extremely small, but this is not small because the membership degree with respect to small is 0. But in fuzzy natural logic, 0 is extremely small and it is also small. This is very natural because in natural language, when we speak about very small, the first thing is that it must be small and then more. So that is the simplest image about fuzzy natural logic. But this is not all. And now we can see main constituent of fuzzy natural logic. Fuzzy natural logic is consist of the theory of evaluative linguistic expression, theory of fuzzy if-then rule and approximate reasoning, and the theory of intermediate and generalized quantifier. And in our investigation, we focus on the extension of this theory. Okay, but first of all, we will go to the basic theory in fuzzy natural logic, which is the theory of evaluative linguistic expression. We know that evaluative linguistic expression is an adjective phrase that is used for evaluating some object value. So in this theory, an evaluative linguistic expression is given by the form linguistic hedges and atomic evaluative expression, where this one is a adjective and this is an adverb. This adverb make the meaning of the adjective more specific. And when we use an evaluative linguistic expression to evaluate a variable, for example, x here, we obtain a sentence which is called linguistic predication. And to make this sentence meaningful, we have to specify context to this. Why? For example, when we speak about a tall man, we have to make this sentence or this situation meaningful. We have to specify the context to the sentence. I mean that, for example, we speak a tall man in Vietnam, and people can understand that, oh, he is about 1.7 meter. But in Czech Republic, people will understand that maybe he is 1.8 meter, and it's totally different in different contexts. So we have to specify context. And in fuzzy natural logic, a context is specified by 3 numbers: minimal value, maximal value, and typical medium value. And the most important component okay, in fuzzy natural logic, not only in the theory of evaluative linguistic expression, is the local perception function. And this is a mathematical function designed to assign to each value of variable an evaluative linguistic expression. For example, we have the height of a man in Vietnam is 1.6, and apply this local perception to 1.6. We will obtain, for example, medium. Okay. And this function is very important. And in this function, k is given evaluative linguistic expression. From that, the function take value. Now the theory of fuzzy if-then rule in fuzzy natural logic. Fuzzy if-then rule is a sentence with if and then, and this predication is called as antecedent, and this is consequence. A system of fuzzy if-then rules is known as fuzzy system. And now, how to learn a fuzzy system from data and how to interpret a fuzzy system, a given fuzzy system. To learn a fuzzy system from data, and here we can see the procedure to this. Assume that we have a data set, which is a set of pair of value x and y. And first of all, we have to specify context to variable x and y. The context is determined by 3 numbers as we presented in the previous slide. So then we have to choose which linguistic expression that we will use for evaluation of the value or these value. So from the set, I mean that, for example, we can choose kx is small, medium, and big. That's all. But people can choose small, very small, medium, very big, significant, big, and something like that. And then apply the local perception function to the data. We will obtain evaluation of data. AI here is an evaluative linguistic expression. For example, when we apply here the function to this data under this context, we obtain very small. Okay. And from the obtained evaluation of data point, we construct a system of fuzzy if-then rule. But after that, we have to remove the redundant rules. Why we have to remove? Because from data we can obtain several rules with the same, which are the same. Okay, we have to remove. Okay, and now how to interpret a fuzzy system in fuzzy natural logic? This is to obtain an output from a given input. Assume that we have an input x0 and a fuzzy system, and how to compute the output. To compute the output in fuzzy natural logic, this is very special. First of all, we choose the most specific rule to the input value by applying the local perception function to the value, and then we obtain the evaluation of them. And the evaluation is one of the evaluation in the antecedent of the system. K is from the antecedent. Okay. And so from this we will obtain a rule using for the computation of the output, and assume that we obtain the rule Ri0, and then the output is computed as a defuzzification of the fuzzy set. Fuzzy set is obtained from the interpretation of the antecedent of the rule. This is the interpretation or fuzzy set, okay, of the consequence of the rule. And the arrow here is the fuzzy implication. And now, our goal is to extend the theory of linguistic description in fuzzy natural logic to make it possible to take into account both probabilistic uncertainty and fuzziness. And now, we would like to introduce the probabilistic fuzzy if-then rule. This is an extension of the original one. A probabilistic fuzzy if-then rule is of this form, where the antecedent is the same as in the original rule, but the consequence, corresponding to each evaluation is a probability value. Okay, and then a system of probabilistic fuzzy if-then rules is a probabilistic fuzzy system. And the same question, how to learn a probabilistic fuzzy system from data and how to interpret a given fuzzy system. How to do it? And this is how we do. Assume that we have a data. This is the same as in the previous slide. How we do? First of all, we will learn a raw system from data. This means that we apply the presented procedure in fuzzy natural logic to the data to obtain a fuzzy system. But raw system, this means that we do not apply the reduction step. I mean, we don't apply this step to remove the redundant rule. So that is the reason why the number of rule here is the same as in the number of data pair. So from the system, we determine which evaluative linguistic expressions are used in the antecedent and consequence by this set. And then we construct probabilistic fuzzy system is a system of probabilistic fuzzy if-then rule here, and the only thing we have to determine is the probability here, and probability here, for example, determined by this. The probability, the conditional probability, this is determined by the number of rules with antecedent AI consequent Bj over the number of rules with antecedent AI. And that's it. And now, how to interpret a probabilistic fuzzy system. Assume that we are given an input in a probabilistic fuzzy system. And now, how we compute the output. The idea is the same as in the original fuzzy natural logic. This means that we will choose the most specific rule to the input, and from the rule we will compute the output. And here, assume that the chosen rule is this one, and then the output is computed by this formula where the probability here is given in the probabilistic fuzzy system. So that's it. And now consider an example to show how the proposed system works with data. We will using the probabilistic fuzzy system to describe the dependencies between the sale of ice cream and the temperature in Czech Republic. And this is the given data. We have, this is sale over these years and the temperature. Okay. And now we establish a probabilistic fuzzy system like this. First of all, we have to specify the contact to the temperature and to the cell. And then we learn a raw system from data. See, the number of fuzzy if-then rule in the system is the same as in the number of data pair. So from this, instead of reduction the size of the system, and now from this raw system we establish the probabilistic fuzzy system, and this is the obtained result. And from this, to evaluate the quality of the model, we estimate the output from the input. The input is temperature and the output is cell. And this is the estimation. This is the estimation using the proposed system and the proposed interpretation technique. And this is the estimation of cell using the original technique in fuzzy natural logic. And this is the correct value, and compute the error. We obtain that the novel system can help to improve the quality. Okay, and this is conclusion. We extend the notion of linguistic description in fuzzy natural logic to make it possible to comprise the probabilistic uncertainty beside the fuzziness. And we believe that the combination of two things will make better than one. So what we do? A novel form of linguistic fuzzy if-then rule is proposed. We introduce the learning interpreting process, and we consider an illustration to show how it works in data. Okay. Of course, the data, of course, the data we consider is really small, but no problem because the goal is just to show how it works. Okay, thank you for your attention. Because of coronavirus, I cannot present in the conference in body, but I hope that question or remark can be go to my email address. And moreover, I would like to thank the organizer of the conference, and I wish the conference successful and everybody enjoy the conference. Thank you.